Alright, let's do a quick rundown of this SWP while I'm waiting on it to start back up. So this is your main blower contact. This is your main power block coming through. This is your overload for your blower itself. Down here on the far end, this is your blower VFD or bypass. So depending on which mode you're in for the drive. If your drive is on the outside of it here, that drive is on a floating point signal. So what that means is these two relays here, depending on how they are fired, it'll either speed up or slow down the drive speed to control static pressure. So as static goes up, if it needs to slow it down, it fires one relay, the drive responds to that signal to it and it slows down, and then vice versa for the speed up. This is your static pressure sensor registering static pressure back to the main controls, and then this here is one of your static safeties. Now the way Mcquay stages their compressors, this is compressor 1, 3, 4, 2. So it's 1, 3, 4, and 2. From there, you're going to move into the controls. So again, these two are both static controls here. One should be our filter control. The other one is going to be fan verification, and then you're going to have a high static control as well. This is your primary output board. So all of your compressor output, your fan output, all that runs through this board. Up top is your your speed control outputs. That is this one here. This is going to be your bypass or drive input output, just identifying which you're going to run in. Your high pressure switches, your mechanical overloads, the actual compressor motor protectors that these have, all that's ran through here. Your inputs, such as your low pressure switch, your freeze protection, your temperature sensors, all of that is done here on this input board, and then they all talk to each other through the main control module via these ribbon cables. So you come over here, this is your main control module. Get some light on the situation. So this is what is the automation's talking to. Everything talks to this directly in order to operate the unit. This is your main brain here, and if this ever fails, if any of these boards ever fail, it's extremely expensive to refurbish them or to buy refurbished ones. You cannot purchase these new anymore. And usually the best option ends up becoming to change this out with a automation system directly, and just have a aftermarket automation controller run this whole system for you, instead of trying to make it work through factory controls. Now, one of the abilities these SWPs have is that valve right there is a water control valve, and what it is doing is the system is looking at that transducer right there on circuit 1, and it is using that transducer to control head pressure on the whole system. Now granted, keep in mind that if circuit 1 is not running, it has no idea what the system head pressure is doing. But as long as circuit 1 is online, and say you had really cold condenser water coming in for any reason, that valve will modulate down in order to control the condenser water flow to maintain a certain head pressure minimum. So, and obviously as the head pressure builds, it'll open the valve and flow back up and so forth. And the theory behind it is the other circuits should be roughly identical to whatever circuit 1 is doing. But again, that is very critical on the fact that all the circuits are fully functional and doing about the same parameters.
So if you have a circuit that's having trouble or is overcharged or something, it may be tripping out because of the valve being closed down, even though circuit 1 is set up differently. So say circuit 1 gets low on charge, you know, the system's going to try to modulate per circuit 1 to keep the head pressure up. Well, that may end up causing all your other circuits to trip out on high pressure. So those are things you have to think about and keep in mind. A lot of people disable those flow control valves. It's not really something that we have to deal with much here in Texas. It's not that hard for us to maintain our condenser water temp at 70, 80 degrees, year round. It's not that big a deal for us. And we don't have trouble with our temps getting too cold, I guess is what I'm saying. We'll struggle with them getting a little hot sometimes, especially in the real deep heat of the summer, but not so much on the cold side. So anyway, that's just another phase and function of the controls. And again, this is a tube-in-tube condensers. So the water is on the inner tube inside, and the refrigerant is on the outer tubes on the outside. And so that's what you're seeing there, is that tube-in-tube condenser on the back side there. So you can see all the discharge lines coming in here, and then your liquid lines coming out the bottom down there. It's very common for these to spring leaks where the strapping and the mounting points are, and so a lot of times we have to come in and cut those straps out and braze or patch where that leak was formed, where it usually rubs a hole. And then usually we can leave the strap out. It's not required to be in there. Sometimes we will weld the piece back in its place, just depending on the situation. Something I do highly recommend on these dryers, because they are very difficult to change given their location. You'd be surprised if you can see how close they are to the valves themselves, and then just the other side of that you've got sight glasses there. And so you got a lot of heat that has to be controlled in a very tight spot, right? I highly recommend upgrading these to flared fittings. Even if you purchase the pre-made flares at the supply house and put those in, that's fine. I really do. I recommend. You're going to save yourself a lot of time, headache. You can see by the braze on those, it's not a very good braze on either of these dryers in front of us. And I can promise you it's because you really struggle controlling the heat and not overheating the valve or something else in the system, and getting enough heat without getting too much heat. It's not easy at all. Even for somebody that's got a lot of experience doing this, I can tell you, I can do it fairly efficiently at this point, but it requires a lot of heat control. You get a lot of guys that are inexperienced with that. They really struggle with it.